Okay, good morning, everyone. Welcome to the Department of Economics, Ateneo de Manila University, and Ateneo Center for Economic Research and Development Seminar Series. My name is Mahalea Rabago. I'm an associate professor from the Department of Economics. I hope the happy music set the mood for today and this seminar. Before I introduce the speaker, let me remind you of some house rules so that we will have a very smooth seminar this morning. First, we will let the speaker finish his presentation before we entertain questions. Zoom participants, kindly stay muted and stop sharing your video during the duration of the presentation. So if you haven't done so, kindly do it now. During the question and answer, please virtually raise your hand and wait to be acknowledged. You may unmute and show yourself when asking your questions. Participants on Facebook, please post your question in the comments section. Slide videos and other materials from the seminar are posted in our website only when the speaker gives his consent for sharing them. Our speaker this morning is none other than Dr. Jesus Felipe, who has been with ADB since 1996. He is currently the managing editor of the Asian Development Review. His research interests spread across areas such as long-run growth in Asia, the dynamics of structural transformation, industrial policy, inclusive growth and full employment, the impact of technology on employment, productivity, and technological progress. Dr. Felipe has also held academic positions with the Georgia Institute of Technology and the Hong Kong University of Science and Technology. He holds a PhD from the University of Pennsylvania. Without further ado, let us welcome Dr. Jesus Felipe, who's going to give us a presentation on his paper titled Endogeneity Bias and Other Problems in the Estimation of Production Functions. Okay, let us welcome Dr. Jesus Felipe.
Let me make sure that I get this one. Thank you so much, Professor Rabago. It's a pleasure to be here with all of you at Ateneo, very good friends for many, many, many years. Thank you so much, of course, to the Econ Department of Ateneo School of Economics. And thank you, everyone, for taking the time this morning. I'm always, when I give presentations, tremendously mindful of the opportunity cost that is involved in attending somebody's presentation. So I'm going to do my best to tell you something interesting and useful this morning. Under the title, as Professor Rabago was announcing, Endogeneity Bias and Other Problems in the Estimation of Production Functions. In case somebody's interested in the paper after the presentation, I put here is already in SSRN with a number that I put there, 385, etc., etc. So what is behind this paper and the presentation, today's presentation this morning? Look, I have no doubt that all of you have at some point in your careers, or those of you who are students are doing it now, estimated a production function. You have calculated total factor productivity. I have absolutely no doubt that all this has been done. The production function is a key pillar of standard growth theories, growth models, macro, labor demand functions, any analysis, of course, neoclassical analysis of the direction of technical progress requires a production function. Production functions are estimated empirically, mainly, there might be other reasons, but mainly to get estimates of the factor elasticities, and obviously to obtain TFP calculations, the elasticity of substitution. Today, I'm going to focus more on the estimation of elasticities and TFP calculations, because this is what the literature that I'm going to refer to has been or deals with. Okay. So today's presentation is about this. It's very, very interesting, and I don't know how much you know about the history of the production function, its estimation, since you all may have heard of the Cobb-Douglas paper, 1928. Between 1928 and the 1940s, production functions didn't really have a great reception in the profession. And since the 1940s and 1950s, there has been a great literature discussing problems with the estimation of production functions. These problems can be linked or lumped into three big groups. The first one is the simultaneity and endogeneity problem. I'm going to talk about it today. Obviously, this is the title of the presentation. This is very, very well known in the profession. The second one is the aggregation problem in the capital debates. This is known, but completely forgotten by most people. And the third problem is the accounting identity, and this is known in some circles, but ignored completely ignored by mainstream profession. And this is really what I'm going to talk today. All these problems are discussed in my book published a few years ago, 2013, with my co-author John McCombie at Cambridge, The Aggregate Production Function and the Measurement of Technical Change, with the thought-provoking subtitle, Not Even Wrong, which is what I'm going to do and talk about today. I do assume that most of you are familiar with the standard framework to estimate production function and total factor productivity. I summarize it here in terms of the Cobb-Douglas production function. The subscripts INT refer to sector of firm, cross section, and T is for time. A is Hicksian neutral efficiency, that is in the standard framework is unobservable, and this is why we talk about TFP and then the need to estimate TFP. This is estimated usually in log linear form, which is what the second line shows. Okay, and the estimation of TFP proceeds by getting estimates of alpha and beta, and then taking the residual of in the production function, and this is what is called in the profession the primal estimate of total factor productivity. But this requires, of course, in the framework that I'm using here, estimates of alpha and beta. Otherwise, one needs to impose the factor, the factor shares in assuming perfectly competitive factor markets, which is also standard in doing growth accounting exercises. But the idea of the new literature that I'm going to discuss is that alpha and beta needs to be estimated. There are two issues that appear here. Okay, one is, of course, fundamental, that once you proceed into with estimation of the production function, you need to obtain unbiased estimates of the elasticities, and this is really the big problem. In particular, when you use OLS estimation, there is a problem of endogeneity of capital and labor. That is, in the sense that there is assume a contemporaneous correlation between the inputs and the error term. Okay, this is the source of the endogeneity problem. What is the source of this problem in the context of the production function? Well, you imagine that firms, for example, that experience an exogenous productivity shock may respond to it by altering the amount of inputs that they offer, okay, that they use. So this is the first point here, in fundamental problem, and this is what I'm going to be discussing, how the profession has solved the endogeneity problem. The second one, fundamental, and that this is going to link my presentation to the other part that I was talking about, which is the accounting identity problem, is that in the standard framework, and you open any microeconomics textbook, and you will read that, of course, output, labor, and capital are physical quantities. This is absolutely fundamental, and this is my notation. Q, K, and L refer to physical quantities. All right, but this is standard in the literature. Keep this in mind, even though I will come back to it. All right. How has the profession dealt with the endogeneity problem since the 1940s? By using different estimators. The standard ones are instrumental variables or least square dummy variables, and the profession has also developed specific estimators in the context of the production function. And this is all the modern literature, for example, the Levinson and Petrine model or method that some of you may know, Ackerberg et al., Gandhi et al., etc. These are very recent papers in some of the top journals in the professions, which really tells you that the topic has really not died. The topic, people are still thinking about how to estimate production functions and get unbiased estimates of the elasticities. Okay. So how am I going to proceed in today's presentation? Well, the key question that underlines the story of my presentation is whether the bias is truly a question of regressus endogeneity or there is something else. All right, keep this in mind. And what I'm going to do first, I'm going to show you estimates of Cobb-Douglas production functions, which is still being used in the modern literature. What I'm going to show you is estimates of the standard OLS, and then 4 other estimators that supposedly deal with regressus endogeneity. This is least square dummy variable, instrumental variable, system GMM, dynamic system GMM, and the Levinson and Petrine method, which was specifically devised to estimate production functions. And the question that we are going to ask is, well, which one gives us the best estimates of the elasticity of the production function? Then what I'm going to do in the second part of the presentation is discuss and evaluate the accounting identity problem. And I anticipate what this problem is, which is that variables are used to estimate production functions are linked through an accounting identity. And this poses an insurmountable problem. Okay, so you will see how the two stories relate. Okay, and if you have never seen or read about the accounting identity problem, it's going to open your eyes about the problems with a significant part of what the profession has been doing for 70 years. Okay, all right. Okay, so with this in mind, what I'm going to do first is show you the estimates of the Cobb-Douglas production function with the 5 estimators. I repeat, OLS that supposedly give you bias estimates. These are the 4 estimators. Then I'm going to introduce the identity argument. Then I'm going to re-estimate this the Cobb-Douglas production function, keeping in mind the accounting identity argument. And then I'm going to answer the question of where does the bias come from? Is the bias really a question of endogeneity? Then I'm going to make a couple of comments. I have here 4 comments, but due to time constraint, probably I'll focus on 2 of them and some conclusions. All right. So this is the program for the rest of the presentation. These are the estimators that I'm going to use. The first one is OLS, standard. The second one, least square dummy variables, also a standard. Then instrumental variables. The version that we use is IV is instrumental variables, 2-state least squares. Okay, and you will notice here that I have slightly changed the notation with respect to that used in the previous slides. I'm not using Q and K. I'm already using V and J, and the reason is something that I'm going to get into, which is that in standard applications, nobody uses Q and K, that is physical quantities, because these do not exist. So what everybody uses is monetary values, however deflated. This is true for output and the capital stock. So nobody uses physical quantities, I repeat, because this does not exist, even at the firm level. Okay, so this is why the notation, instead of using I insist K and Q for output, I use V and J. L is the only one that is really a physical quantity. So these are my first 3 estimators. This is GMM, very standard also, a system GMM. This is the level. What I put on top is the level in the first difference equation with my moment conditions here. All right, and the last one is the previous ones are standard, so I don't stop because these have been applied in many contexts. The only one that really was developed specifically for estimation of production functions is Levinson and Petrine. This is a paper in 2003, Review of Economic Studies. This is even implemented in Stata, so widely used, even though recently has been criticized in the recent literature. Okay, and it consists on 2 steps. Basically, the essence of the Levinson and Petrine method is that it solves the simultaneity problem of the regressus, capital and labor, by using intermediate inputs to a proxy for the unobserved productivity shock. So what the Levinson and Petrine method does is to split the error term that you see in the first line, the error term epsilon, into 2 parts, theta and u. And theta is a transmitted productivity shock. This is the one that is not observed to the researcher. The second part of the error term U is the standard one that is uncorrelated with input choices. All right. So what Levinson and Petrine do, which is a semi-parametric method, is to use intermediate inputs to proxy for unobserved productivity shocks. The production function is written the way it appears in this rectangle here. In the first step, is a very simple OLS regression of output V on employment L and high order polynomial of J, which is capital, and Z, which is intermediate material, which is the proxy for the productivity shock. The first step gives you the estimate of alpha okay? The elasticity of labor, which in this context is the freely variable input. Capital is the state variable. So the first step, you run this regression, which I insist is the regression of output V on employment plus this high order, in this case, third order polynomial on capital J and intermediate inputs. The second step is to consistency minimizes the sample residual that comes from the first step. Okay, and this is done in the context of using this grid search. So you impose the alpha hat estimated in the first step, and you minimize this function, and then this is what gives you the estimate of beta, the elasticity of capital. So this is done in two steps, and this is why it's a semi-parametric method. All right. So these are the 5 estimators that I'm going to use. Going quickly into the results, I get later into the data set that I use. But basically, I have here 25,000 observations that corresponds to approximately 54 periods, 473 sectors. This is from the US, the NBR data set on manufacturing. Okay. So what are the results? Well, the results are here. And just very, very quickly, the question that I pose here is, which one of these different estimators, in particular the ones that supposedly solve the endogeneity problem, is the one that gives you the best results? If you take a quick look at the results, at the estimates of the elasticities, they are all over the place. All over the place, from the elasticity of employment from 0.47, 46, 47, 37 in the case of the Levinson and Petrin, up to 0.73. If you look at capital, it's almost the other way around, from 0.33 in the case of system GMM to almost 0.8 instrumental variables. If you look at the degree of returns to scale, from approximately constant returns to scale to significant increasing returns to scale. Other than, if you look at the first column with OLS, the argument that we write in the paper is that other than for theoretical reasons, not clear why OLS results are really worse than any other results within any other estimation method. What I'm concluding here is really what Van Beveren concluded in a survey on estimation of production functions and TFP. This is a paper in the Journal of Economic Surveys. She concluded that in practice, evaluation of factor elasticities is more problematic due to the absence of a definite prior or on how high or low factor elasticity should be. So she's arguing, said, look, I do not really know what these elasticities should be. This italics is in the original. So this poses a question. You start using different estimators. Why one is better than the other one? This includes, I insist, OLS, which theoretically gives you bias estimates. Okay. All right. So let's go with this background. Keep this in mind. I will bring this table again in a couple of minutes to the presentation, to the identity argument. And the identity argument is not new. What is really ironic is that this has been known since the 1950s. The first time that the argument was put very clearly was Phelps-Brown and QJE. But then afterwards, no other than 2 Nobel Prizes, Herbert Simon and then Paul Samuelson, rehearsed the argument in the 1970s. So econometricians such as Kremer, Intriligator, and Wallis also have their argument in their econometrics textbook. And it's really difficult to understand why the profession has not really caught on it. So let me get to the argument in simple terms, because it's not difficult to understand it. What the argument says that all estimations of production functions do is to pick up the distribution accounting identity according to which V output is equal to the total wage bill plus total profit, so W plus P. This accounting identity, notice that holds at every level of aggregation. This is true for a company, for a sector, and for the total economy. The total economy, this will be the GDP from the factor side, from the cost side, that you go to the national accounts of the Philippines. So you will have V distributed between outputs and profits. Okay. So how does the identity argument operate? In very simple terms, is the following. Before I get to it, let me remind you of something that I just pointed out at the beginning of my presentation that is fundamental, which is that the series used to estimate production functions, despite what our textbooks claim, are not physical quantities, which I denote here as Q and K. L is the only one that is really a physical quantity, but in reality, everybody uses V, which is deflated output, and the capital stock J, which is a complete mess of how it is estimated, some sort of perpetual inventory method, but it has really nothing to do with physical quantities. The irony of this is that this is admitted by all the recent literature. So what I quote here is all the papers that have appeared recently, that they clearly say, yes, to estimate the production function, I should use physical quantities, but in reality, I don't have them. So basically what the new literature is trying to do is using value data, acknowledging that it's not the same as physical quantities, try to identify the coefficients, which are the elasticities of the true production function by imposing certain assumptions. This is how the recent literature proceeds. So with this, what is in a nutshell the argument of the accounting identity? Look, if you write the accounting identity in the first, the way I have it in the first row, is you have output, I insist, V equals the wage bill plus profits. This is an accounting identity. What this means, let me remind you, and this is for the students in particular, there is no error term here of any kind. Certainly there is no random error, whatever you want to call it, epsilon, U, etc. You write this accounting identity in growth rates, and this tells you, this is what I have in the next line, that the growth rate of output equals the growth rate of the wage bill plus the growth rate of profits, each of them weighted by what? By the factor shares. And in doing this derivation, you don't impose any assumption. So V hat equals A W hat plus B P hat, where A and B are the shares in output. Okay, I hope everybody can do this. This is very simple. And I insist this continues being an accounting identity. Now you assume that you are doing this for a sector, a country, or where factor shares are relatively constant. For the sake of the argument, let's assume that these are perfectly constant, and then you integrate back the second line. Okay, so I hope everybody can do this. So if you integrate the second line in growth rates, it's gonna give you the expression that I have in blue, which is A times W raised to A times P raised to 1 minus A. And I hope everybody understands that this expression in blue continues being the accounting identity, is the same expression as the one in the first line. All I have done is to take the derivative and then integrate. They're identical. And if you don't believe me, get a data set and you calculate, you sum W plus P, it will give you V, and then go down to the bottom and you do this operation, it will give you the same number. So the question that I pose is, would you estimate this regression? I hope all of you tell me no. And I'm looking at all of you, trust me, even though I cannot see you, because this is not a model. This is an accounting identity. You do not estimate accounting identities. So what would happen if you, for any reason, go ahead and proceed and do it? This is, and then you write your regression the way I have it in the last line in brown. Well, what would it be the estimates of alpha and beta? I hope you tell me that you don't even need to run the regression, because you know that alpha and beta will be what? A and 1 minus A, the factor shares. And what will be your R squared? Well, because you're estimating accounting identity and there's no error term, your R squared will be 1, of course. I hope everybody sees this, okay? So how does this apply to the accounting identity? How do we get here J and L? Well, you get J and L because you notice that the accounting identity, my big W can be written as the product of an average wage rate times employment, and P, profits, are an average profit rate times J. If I do the same thing I have done now, which is to write this in growth rates and integrate, I get the expression here in the middle, which is the same one as before, but now you will see WL raised to A is my big W, and R times J raised to 1 minus A is P. Continues being the same. But now you see this way I have introduced already L and J. And you will see that this is your standard Cobb-Douglas production function with one important point, which is this adds W and R. So I'm not saying here that to estimate the production function, you need to add W and R. I'm saying that if you introduce here a variable that proxies very well W and R, you will hit the accounting identity. And if you do not do it, you will get bad results, which is what has characterized the profession for 70 years. And this is why people believe that the estimates of alpha and beta are biased, because of the bad approximation to W and R through different forms. Sometimes people use human capital. Well, if human capital happens to be a good proxy for W and R, you will hit it. But if not, your production function will be a disaster, okay? Not to mention, we will get back to this in a second, that what the profession calls total factor productivity is unobserved. I claim that is perfectly observed, is the weighted average of the wage and profit rates. This is TFP, and I will get back to it in a second. All right. So with this in mind, let me tell you what this means, and then we get back to the estimation of the production function. First, what this implies is that the estimated factor elasticities, when you estimate the production function, they must be equal to the factor shares, always. Although this does not provide any empirical evidence that factor markets are competitive. The second one is that the estimated elasticities, of course, they will adapt to 1, but this cannot be interpreted as evidence of constant returns. This is simply the accounting identity, and the profession has been doing this for 70 years. And of course, when you get, and this applies to anything, when you get an R-squared estimating any function in econometrics, be very suspicious. Don't think that you're a good econometrician. In the case of the production function, it's very clear that what you're estimating is the accounting identity. It's not that you are a great econometrician. All right. So be very, very mindful of this. So with this in mind, let's get back to the re-estimation of the Cobb-Douglas and see what happens when you know that what you're estimating is an accounting identity. This is the data set that I use. I introduced it before briefly. Is the manufacturing industry database of the NBR. I was right. 473 industries, 54 years. This gives me my 25,000 data points. The nice thing about this data set is that it allows me to construct the accounting identity. So I can get my W, my R, and Z, which is intermediate materials. I don't show you here the results for gross output. So I'll continue working with the value-added production function. So this is not a problem, but I can construct the accounting identity. This table, for you to keep in mind, I'll get back to it in a second. In my data set, the average employment share in value added is 0.41, and the capital share in value added is 0.59. You will see the results now. That's why I'm showing you this. And this is the accounting identity again. Now, you will see that this table is the same one that we discussed 5 minutes ago when I was introducing the story, when I was talking about the Cobb-Douglas. But you will see an important difference is that now what I explicitly do is introduce the wage rating, the profit rating, the estimate, because I know that this is the accounting identity. So again, I insist, I'm not asking you to introduce W and R when you estimate a production function. In fact, the purpose of the presentation is that you should never do this. Estimate a production function is useless. It's a useless exercise. But what this tells you is that once you do it, you're hitting the accounting identity, no matter what econometric method you use. You will see that in all cases, you're essentially getting the same result. In all of them are perfect. All of them add up to 1. If you adapt the wage rate plus the profit rate or employment and capital, they add up to 1. The R squared is virtually 1. Of course, in this actual data set, there is a slight variation, but I'm very, very, very small for purposes of what we are talking about. And that again, I insist, no matter what estimation method you use, you get essentially the same results, not like before. Remember that we were getting elasticities of almost 0.8. This is gone. And I just told you a while ago that the average employment share is in my data set is 0.41. Look at my estimates of the wage rated employment. Basically the same, very close to it, in the estimates of the capital share also in the neighborhood of 0.6, which is the average of my data set. I insist in all cases the degree of returns to scale is about 1 in all cases, and the R squared is 1. It's virtually the accounting identity. So I insist. I'm not saying that when you estimate a production function you need to add W and R. All I'm saying is that if you add a variable that proxies very well W and R, you will continue hitting the accounting identity. And hitting the accounting identity simply means that you know the results ex ante. So why would you do it? All right. So I repeat what I was telling you before. The estimated factor elasticities must be equal to the factor shares. I'll just show it to you. But this does not provide any empirical evidence that factor markets are competitive. It's simply the identity. the elasticities add up to 1, but this has nothing to do with the reality of constant returns to scale. It's just the identity. And I insist, the fact that you get an R square close to 1 should not make you feel that you are a great econometrician. Quite the opposite. It simply says that you just hit an identity. That's all. Okay? All right. Very important thing. Is the bias due to simultaneity? And what we are arguing is, of course not. Look, if you have, let's assume that you estimated the Cobb-Douglas production function the way it appears in the first line, but we already know that the true model is the identity what appears in the second one. So what is the difference between both of it? Is of course the omission of what I call here M, which is the weighted average of the wage and profit rates. So how can you calculate what is the bias in the estimation of alpha and beta? Well, you substitute your true model into the OLS estimates. You take expectations, and this is what appears in this line here. So what this tells you, this is a very important result, that the expected value of your alpha hat OLS, it has to be equal to the labor share plus something else. That something else is what you call the bias. And the same thing happens to the estimate of beta, which is the elasticity of capital. It has to be the factor share, the capital share in the national accounts, in case you use aggregate data, plus something else. Now, that is the bias. And this is the standard result in omitted variable, the discussion of omitted variable bias in econometrics. But there is a big difference here, is that when you discuss omitted variable bias in econometrics, you do not know what is the omitted variable. You do not know. Here you know that what you have omitted is M, so it's W and R. You already know it. And the second difference with the standard analysis of omitted variable bias is that, of course, you have a regression where you have a true error term. Here, there is no error. The error that you make is simply the omission of M, but M is not your random variable, epsilon, when you estimate a true regression model. You know what you are omitting. Therefore, this has nothing to do with doing what I call serious econometrics. Okay? All right. Let me make a couple of comments. I'm not going to make 4 comments due to time, just 2 comments. The first one is, well, an example of how can you get back to the accounting identity. So let's get back to the least square dummy variables. Remember, what least square dummy variables, which is one of the 4 estimators that I show you that try to deal with endogeneity problem, is you use dummy variables. Of course, these dummy variables are for sectors. Okay, so what we do here is something different. What we construct is dummy variables, but for this variable that is M. So I calculate M for all my units of observation, and I rank them. And I construct and I put them into 200 groups from the smallest to the largest. So my DM are 200 dummies that are M from the smallest to the largest into 200 groups. Okay, so this is what I do. And I estimate this. I'm going to show you the results for 1 year, 2011. For the year 2011, the employment and capital shares are 0.31 and 0.69. And this is the result. So for you to remember, this is what I show you in table 1, least square dummy variables. The employment elasticity was 0.46 and the capital elasticity was 0.79, really far from the average factor shares. Now look at what happens if we do this for the year 2011. For the year 2011, I just said that the factor shares are 0.31 and 69. Look at what we obtained with these dummies, 0.28 and 72, really, really close. Again, the R square is almost 1, and the degree of returns to scale, of course, it has to be almost 1. So this one, what I'm doing is mimicking the accounting identity. I'm not doing anything that you didn't know before running the regression. I'm going to skip these 2 and go to the last one, and I finish the presentation. I think I'm okay in time. And it's a comment on TFP, because that was the other thing that I wanted to discuss. Apart from the first comment that you should be very careful calculating TFP, because it depends on the units of the variables. This is a minor issue. The big one is the interpretation, is the second point. Remember, TFP, and I'm talking about the primal, not the dual, is a different story. The primal in a standard neoclassical theory is that TFP or TFP growth captures the shift in the production function, keeping inputs constant. This is fine, but remember, all I have done here is to manipulate an accounting identity. So what the accounting identity tells you is that, well, TFP is not a measure of our ignorance. by construction, TFP is the weighted average of the growth rate of the wage and profit rates. If you go to the second line in growth rate, because this is the one that people tend to use more, your TFP is calculated residually as the growth rate of output minus the growth rate of inputs, each of them weighted by the factor shares. But what the accounting identity tells me is that this is exactly equal to the weighted average of the wage and profit rates. So what we argue is that these equations are correct by definition, and this is true. But why interpreting this as a shift in the production function when all I have done is to manipulate an accounting identity? This is at best some sort of measure of distributional factor rewards, something like that. But one will have a lot of imagination, because then you need to think that you're estimating a production function when I just show you you're not estimating a production function. All you're doing is reproducing an accounting identity. So I hope this gives you some doubts when you want to deal with this concept of TFP. That is really nothing but this weighted average of the growth rate of the wage and profit rates, which is correct, but the interpretation, I insist, as productivity really requires a lot of assumptions that are probably not true. So let me close with this thought-provoking statement here that I think the profession has been working up the wrong tree for 70 years. Remember, I began by telling you that production functions are estimated with value data in reality, not with physical quantities. And this poses a tremendous problem. The problem is that data with value data or constant price value data, I mean deflated, are related through an accounting identity. This problem has been known since the 1950s, but completely ignored. And you have a monumental literature in the profession about production theory, which is really about using value data. What I have shown you today is that the estimated elasticities, if you do your exercise correctly, must always be equal to the factor shares. But this has nothing to do with competitive markets and constant returns to a scale. If you don't obtain this result, is that you have done something wrong. Call me. I'll sit down with you in the computer, and I guarantee you that you will get this result. I have also shown you, and I hope, that there is no endogeneity bias in the traditional sense of the term that is caused by regressive endogeneity, because all you're estimating is an identity. If you have an identity, you don't have any endogeneity problem. There is no error term. The only mistake that you're making, the only problem that we have, is that there is this term, which is the weighted average of the wage and profit rate, that is being omitted. And this gives you the illusion of having an endogeneity problem. All the methods discussed in the literature to overcome the endogeneity problem, if for any reason are correct, in the sense that they give you elasticity close to the factor shares, is pure serendipity. It is because they managed to track well the accounting identity or some transformation of it. Otherwise, I think simple OLS would give you the good results. This is what I have been doing during the last 30 years. You give me any data on production, with production on labor capital and output, and OLS would do well. Okay. TFP, yes, absolutely. You can call whatever you want this residual, that is the weighted average of the wage and profit rate, but this has nothing to do with productivity. The way it is understood in neoclassical theory, which is the shift of the production function. I insist, to do that, you will have to have a production function that you have estimated. But I argue that that's not what you estimated. You estimated an identity. Therefore, yes, you can calculate it, but it's not productivity the way I insist it is interpreted in neoclassical economics. And I just close with the statement that the estimation of what you think is a production function, what I call a putative production function, using constant price value data, does not provide you any evidence of the underlying technology of firms or sectors of the economy, which is the purpose of estimating production function. It's just all you're doing is this exercise of reproducing the accounting identity. There is no solution to this problem, so this has nothing to do with getting another estimator, however complicated. The only solution to this will be to really get physical quantity data, but these data do not exist. The estimation with physical quantity has other problems that I can discuss later if somebody is interested during the discussion. So I would say, I really hope that after 70 years we can put at peace and rest in peace to the production functions. With this, I'm going to stop, not without thanking you for your attention. I hope I have done this in about 40 minutes, and I put there, in case somebody's interested, the SSRN number of the paper that I've been discussing. So thank you so much again, and back to you, Maja. Thank you.
All right. Thank you very much, Jesus. Very interesting and enlightening. I'm sure we'll have a lot of questions from the audience. So at this point, may I invite those who are in Zoom to ask any questions to Jesus, to Dr. Felipe. Also on Facebook, you can write your question on the comment section and we will read them out for you. Anybody from... Let me see. Any question?
You're mesmerized.
Yes, Jeff, you may unmute yourself and show yourself.
Hello, good morning, Dr. Felipe. It's very interesting and very insightful presentation. I thought it was in the nature of great insight. It was, after it is explained to you, it seemed quite obvious. But before it was explained to you, it was actually that difficult to understand because we've been used to seeing the TFP estimated that way before. My question is that, well, TFP is a model, so it's as it was explained to us when we were studying it, it was a means to sort of measure technological progress. What would you recommend will be the alternative to measuring that TFP or technological progress? Do we just give up on it? Especially as you said that it's actually sort of like very difficult, if not impossible, to measure physical quantities. Yeah, thank you.
Thank you, Jeff. Can I ask Maha? I'm sorry, answer.
Yes, you may.
Right. Thank you, Jeff. Thank you so much. I really appreciate your question because it is a logical question to my presentation. The logical question is, well, if you claim what you are claiming, what can we do? And the answer is not simple. Can I ask? There is somebody with the mic on, and really the noise came. Would you mind? Yeah. Thank you so much. Thank you. All right. There are two things. Let me start with the negative part. The negative part is that the only reason why you talk about TFP is that the only model that you have been taught in a school or that you teach your students to understand macro and in particular growth is the neoclassical growth model. The neoclassical growth model where you have a production function, etc. And this is how you introduce the proxy for technological progress, and this is how you go into the story of TFP, etc. And this is what you correctly or incorrectly refer to as the model. In the context of the neoclassical theory is the model. Part of what, or an important point of my presentation, that this is not a model. And it's not a model because it is not testable. Testable in classical statistical theories that you can refute it. That is, and what I'm telling you is that no, you cannot refute it. Every time you estimate a production function, you're always going to get the result that yes, if the data fits well, and I get constant returns to scale, etc. So remember that this is a way of thinking, and it's the only one. So when you say what is the alternative to TFP? Oh, none. There is nothing. There is nothing. But you need to understand something much deeper, which is what is the notion of technical progress when you talk about an economy? It's absolutely meaningless. Meaningless. In neoclassical economics, the reason is the following. To talk about technical progress at the aggregate level in the neoclassical context, you need something called an aggregate production function. For that, you need to aggregate, which is something that also has been known since the 1950s and 70s that you cannot do. So I'm going to ask you all, I'm going to give you an exercise, and you come back to me via email. You have 10 firms in this economy. I hope you agree with me that all of them will have different production functions, because one of them is going to be, or two of them are going to be in agriculture. Somebody is going to be in producing tomatoes. Somebody else is going to be making pineapples. And then you're going to have somebody in manufacturing and somebody in services. And all these production functions are different because they use different output. They have different labor and different capital stocks. Can anybody aggregate those production functions? The answer is no. This has been known in the literature. So what are we doing? When we work with something, this Y of FKL is meaningless. So the idea of technical progress at the aggregate level is very, very, very difficult to really entertain. This is something that I would do at the micro level. At the micro level, the estimation of the production, which is something that I could understand, that you could talk about technical progress for a firm. Now, what is the problem here? The problem is that you need to have good data on physical stocks, and this is very problematic for the capital stock in particular, Geoffrey. The other one is that you need to know the form of the production function. And you imagine, if you are thinking, for example, about an oil refinery, what would you estimate? What functional form would you estimate if you have an oil refinery? Extremely, extremely difficult. So you may have data in physical quantities, but estimating is very, very difficult. So this is the negative part. The other part is, and I just do it in passing, tell you in passing, is when I estimate growth, when I talk about growth, I use different models. Not only that, not only what I have said, but there is something very important. This is something that people do not tell the students. When you explain growth or you use the neoclassical growth model, you are telling me something very deep, which is in the Philippines, for example, you're telling me implicitly or very explicitly is that the restrictions on growth in the Philippines are on the supply side. There is no demand side in the neoclassical model. So once you start telling me that you represent output of the economy through a production function, you're telling me that the restrictions on growth of the economy are on the supply side, something that is very difficult to believe for me. So when I talk about growth in the Philippines, I use other types of models where, for example, the restrictions on growth appear on the balance of payments on the demand side, which is a different story. But these models do not consider technical progress the way they appear here. I talk about technical progress, for example, talking about price and non-price competitiveness, how non-price competitiveness has been increasing in countries like the Philippines through, for example, an increase in the income elasticity of exports, for example. There's a proxy for technological progress. So I think this is a very, very pertinent question. You're opening Pandora's box, and if you want, we can talk about this. But my answer is extremely difficult. Please do this exercise. Technical progress at the level of an economy is a very weird idea, very, very complicated notion. Thank you so much for your question.
Okay, another one question? Anybody from Zoom? Let me just scroll my screen.
Professor Perny is there.
Oh yeah, Ernie?
Just what? Sorry. Yes, Jesus, good to see you.
Thank you, Ernie.
Yeah. I think a major issue that you're bringing out is it's not good to you to in a model. You should not be using. You should not be mixing values and physical quantities, right? That's one thing you are bringing up. But I think in many exercises, if there is a physical quantity, or if there's a value numbers, but no physical quantity, then the value numbers are supposed to proxy for the physical quantity, don't they? Is that not acceptable in a in a functional model, functional equation? Y is a function of x, for example. For example, what are the determinants of foreign direct investment? It's not quite a production function, but then you would have on the left-hand side, you would have foreign direct investment. On the right-hand side, you would have different kinds of factors that are considered to have an influence on foreign direct investment. So I'm going a little bit out of the production function issue that you're bringing up. I'm just talking about many regression equations that that use values as well as physical quantities together.
Thank you, Ernie. Is it okay?
Yes.
Yes, yes.
All right, thank you so much, Ernie. Also good to see you. Really appreciate it, because this allows me to elaborate a little bit. Your point is well taken. We will have to see the particular case or cases that you're talking about. The investment example that you bring is a bit tricky, is because remember, in neoclassical theory, and you pointed out, the investment function is derived from a production function. So it's a bit tricky. I will have to sit down with you and see exactly the functional form that you have in mind. Now, let me get back to what I was talking about. I'm not inventing this. All neoclassical production theory is about physical quantities. It's not just me. You open any textbook, and for good reasons. It's about production and productivity. In neoclassical economics are, first of all, micro concepts, and second, about physical quantities. I have no doubt. So what is, this was, if you remember, and you're a bit older than I am, you must be familiar with the Cambridge debates. The Cambridge debates began exactly as asking Joan Robinson, as Solomon Samuelson, is like, what is this thing that you call the production function, but you have values here? All classical production theory since the 19th century, all authors were discussing physical quantities. Now you come up with these values, and this has a lot of problems, and these were the debates in the 1950s and 60s. But it was also discovered very early on was the story of the accounting identity, that the first paper that pointed this out was in 1957 by Phelps Brown. Is, let's assume for a second that what you are saying, Ernie, is correct. What is the problem? Well, the problem is what I just showed, is that while variables in physical quantities, and this is shown in the paper, are not related to the accounting identity, and therefore you would potentially estimate your production function, you will have other problems. The problem I just mentioned, what is the functional form? As soon as you start using value, the values are related to an accounting identity. So when you estimate the production function using values, in reality, all you're doing is mimicking this accounting identity. So this is the real problem. I have a paper where I derive the investment function. This is a Jorgensen paper, and it happens to have the same problem as the production function, precisely because the investment function is derived from the production function. But this might, what I grant you is that what I have discussed might not apply to every single case in econometrics. No, I'm not claiming that. I was talking about production functions. But I hope you understand that the issue, really, this was the Cambridge debates that John Robinson and others brought up. Is a look, all production theory, neoclassical production theories are physical quantities. So what is and this lasted for over 20 years. So I insist, if we are talking about production functions, I think what I'm saying is correct, but there might be other cases where you are right. We'll have to sit down and see. Okay.
Okay. Thank you. Thank you, Jesus.
Thank you. Okay. Any other question from Zoom? Just unmute and show yourself. Let me just scroll. Okay. May I ask a question, Jesus? So just a follow-up to the two questions that was raised earlier. Isn't it, or maybe you can enlighten us, isn't it that economists are using value because it's a sort of conversion metric so that we can compare the physical quantities when we try to estimate such things? Let's say, for example, in agriculture, right? Even though we're talking about just one sector, the quantities for the different subsector within agriculture may not be comparable, so that we are using value instead of the physical quantities.
Thank you, Maha. As you say, this allows me to elaborate. I think you might be right, but remember, all this literature acknowledges that authors begin by saying, if I had or if I could, I would use physical quantities. So the reason why I use values is not to compare, it's simply that I don't have physical quantities. Okay. Now, this poses another problem, which is the comparison. Yes, once you start talking about bushels per blah, 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 this cannot be compared with tons of steel. So be it. So be it. That is, the fact that something has been done in the profession for 70 years does not justify its use. It's simply, that is, the fact that these two things cannot be compared, well, they cannot be compared. And then you get the illusion that because you're using dollars or peso per hour or peso per worker, you can compare. And then you end up saying the productivity of this sector is higher. Well, that's not productivity. It's something else. I don't know how to call it, but this is incorrect. And remember that I insist that in your classical economics, all this, the idea of productivity is always in terms of physical quantities. I think there is a misconception here and a big problem. And you're absolutely correct. The idea of comparing. What is really true is that remember, productivity and production are technical concepts. Mm-hmm. Once you introduce values, you're leaving the technical part of the story. It's not you're comparing apples and potatoes, and because you put everything into peso doesn't mean that what you're doing is correct.
Okay, so that brings us to when we are measuring GDP. It's also the same, right?
No, because GDP is by nature a value measure. In GDP, the way the statisticians, one thing is, this is a very good point. One thing is to calculate GDP through the national accounts as from the demand side as private consumption, private investment, etc., or through the sector side, value added of agriculture plus value of industry, etc., or through the income side, wages plus profit. That is correct.
Okay.
The other thing is the model that Jeff was talking about, which is the production function. That's a different story. Now you say the production function is a model. GDP calculated the way we were saying is just an identity. It's correct. It's values. That is the problem. Exactly. I mean, this. I hope this brings the story home.
Yes. Yes. Okay. So Edsel is asking a question. Edsel, would you like to ask your question? Edsel. Okay.
Yes, Susan. Could you talk more about the alternative production function approach, alternatives to the production function? I think you mentioned earlier about BOP constraint. That's Fairwell, right? And maybe Verdun approach.
I didn't, but you read my mind. Yes, this is what I do, but I do it for a number of reasons. One of them is the problem that obviously, given my work and what I have done for many years, the problems that I have understanding a production function. But the other one is this philosophical issue that I added that nobody seems to realize. When you talk about growth, you think of a development context like the Philippines, and you begin thinking about a production function, you are telling me that the restrictions on growth of the Philippines are exclusively on the supply side. And that is not true. The main restriction on growth of the Philippines is on the demand side. And that is why I use the model such as the balance of payments constraint growth rate, which tell me that in the long run, the biggest problem to growth of the countries like the Philippines is the need to maintain or to avoid a current account deficit. And this is the way I understand. And this allows me to talk about price and non-price competitiveness. I have a paper on that that I just sent to a journal. I hope is accepted. It's a very interesting story talking about the future of the Philippines. This is actually a paper that I began writing before the financial crisis, and I was betting that the Philippines has been doing very well in recent decades, and tried to explain it in terms of, for example, how the income elasticity of demand for exports in the Philippines has been increasing, meaning there has been some element of a structural transformation in the Philippine economy. The Philippine economy has moved from being a very simple economy, producing and exporting agricultural products and very simple manufacturers, to something slightly different. And this is really the essence of what has happened. And that's what I was calling this, going back to Jeff's question, a proxy for technical progress, not the way it is done in the production function, but this way. But I keep in mind something very important, that when you talk about growth and you start with the production function, you're telling your students that the constraint on growth on the Philippines is on the supply side. There is no demand constraints. So this is why I talk at Edsel was provoking me to talk about the balance of payments constraint growth model that I use. Thank you so much for inducing the conversation.
Okay, thanks, Edsel. Okay, anybody, any more question? Okay, so So one last question. So given that you're saying that the residual measure of TFP is not really capturing TFP, so do you recommend for economists or the students to still use the kind of estimation but with a caveat, or do you recommend not using it at all?
Oh, that's a very tricky question the way you pose it. Now you're really getting the gray line. You're really going beyond Ernie Pernias when I say gray line. You see, at some level, suppose that the same way that you get, everybody uses, remember, the accounting identity from the demand side. That is, and you do the most obvious way to explain growth exposed in a country, and you would see this in all reports, the government or ADB or IMF or World Bank is the growth of GDP equals the growth of consumption, the growth of investment, growth of government consumption, etc., each of them weighted by the shares. Now, you can rearrange this accounting identity however you want and put a term on the left-hand side and another one on the right-hand side, and you call this whatever you want. You follow me? You could say growth rate of output minus the growth rate of consumption weighted by the, no problem. And you want to call something special to the right-hand side, no problem. You're doing the same thing with the accounting identity from the income side. From the income side, what you have is the growth rate of GDP equals the growth rate of labor, the growth rate of capital, plus the growth rate of the wage rate, the growth rate of the profit rate, each of them weighted by the shares. You can rearrange this identity however you want, and you can call the left and the right-hand side whatever you want, including TFP. I have no problem with that. So you can use this accounting identity, for example, to close a model. I have no problem with that. Now, when you jump into, you say, oh, this is derived from a production function, and this means productivity is when you and I stop being friends.
Okay, okay. That's a very good clarification and recommendation for the students. Okay, it's already past 11. So before we have our the usual photo opportunity with our speaker, let me invite all of you first to our next seminar, which is going to be on, wait, do you see the share? Do you see? Okay. Okay, this is going to be on August 25, and our speaker is Professor Illinois from Victoria University of Wellington, Chair in the Economics of Disaster and Climate Change. And the topic is on inequalities in climate change-induced flooding during the Hurricane Harvey in Houston, Texas in 2017. And that will be on August 25, 2000. August 25. Okay, and the materials from the seminar will be available in our website. Okay, so